Hello, and good afternoon. I'm Lindley Hinserling, and with me I have Amit Shah from Amazon, AWS, and Shai Peretz from Riskified, and Ajul Hadwavan from Freewheel. So we've got a great talk today. I'm going to talk a little bit about the pressures of AI, ML, and what we have to do to really apply it in the real world. So there's an extreme pressure to exploit this new technology, but it has a countervailing issue of cost that comes with it, and the need for ever more data to be applied. And we've got a number of people here with us today that struggle with this and deal with it and solve this problem every day. And we'll get into that as we go into the presentation. But AI can be a great cost savings in terms of what you can do with it, how you can make your business more efficient, but it comes with expense in the real world in terms of the computing power, the storage you need to use it effectively. So it's interesting to look at some of the stats on how much computing consumes of overall electrical consumption. It's gone from 1% to 2% in 2018, and this is like in a very few years. And then in 2030, it'll be in the multiple digits, 8 to 21%. Training an AI model uses a ton of carbon. And then the industry in general is bigger than the airline industry in its energy consumption. But we save a lot from applying technology to the problems of the world. And I say it that broadly, that AI is going to solve many problems, including energy consumption. But we have to be conscious at the same time of spending that. And a lot of that is dealing with the massive amounts of data that have to be applied. Okay, and it's massive amounts in generating the LLMs, but also in the operational data that has to be affected by the application of LLMs. And so we're constantly, as enterprises, ingesting data all the time, because none of this is of great value unless we can apply it in near real time. One of my jokes, had a long career in tech, I feel like I've been chasing the present forever, okay? What we're trying to do is have context for what's happening right now and be able to apply it right now, okay? So being able to ingest, to build models, to apply those models in real time to get answers as things happen, but with the context that's required to give an accurate answer given the state of the world, the state of your business. So you're going to hear from two of our presenters today about how they use Aerospike as a feature store and why they chose to use it. And it's a question of efficiency in being able to apply more data in a decisioning process in a time-constrained SLA. And then offline stores where you're constantly ingesting new data, both for training but ingesting data that's happening now that you're going to apply those features against to make decisions. And the closer you get to synchronizing all of that, the better outcomes you have. And there's always the metadata about the data you have that you have to keep track of. So Quantcast is a company that uses us for these. And you know, they have 10 billion records. Store data of 8 terabytes and applying that for the historical contextual stuff, and then get lookups in 1 millisecond so that they're never very far behind what the customer's doing, or the data they have on the customer, or the data they have on the context. We also have an e-commerce provider that is in Japan, who's a fashion provider, and they have to provide the context in real time, but they have to be able to know that Taylor Swift changed the color of sweater she wears, so that they put that up in the basket rather than the one she wore last week. All of this takes a complete data platform. So we have an amazing real-time database, but that's not the complete story, because we have to provide the ability to fit that database into an overall data pipeline with multiple points of ingestion. Every one of our customers has many, many different components that are coming in, and you also have to be able to shovel that data to where it needs to go for learning, and then be able to apply it. We've recently added a graph capability with all those same characteristics. We're also working on vector, and we'll do vector a little differently because we care about this time-bound SLA and the ability to apply whatever data type you're using to drive decisioning. So think RAG, okay, and being able to apply that in real time against the database of vectors that is commensurate with the context that you have to apply to the generalized LLMs. So we also care about efficiency and have exploited Graviton. You'll hear a little bit more about that from Amit. And we're architected for efficiency. Now, the big thing that we're focused on is being able to take advantage of whatever instance types, whatever types of networking that the cloud providers are giving to us, and exploit that. But we do it with the ability to scale out, to scale up, with specific technology that we have. And we support geo-distributed transactions. So think synchronous active-active. So we can do transactions West Coast to East Coast on Amazon. We do this today for payment providers, where that you can lose a whole region, you can lose a whole data center, and it keeps working and no data is lost. And we have massive parallelism. And this is at the heart of our ability to support the tremendous throughput that you'll hear about from Shai and Ujjwal. So with that, I'm going to ask Amit to come up.
Hello. Can you guys hear me? Awesome. Hey, my name is Amit Shah. I lead the product management for AWS EC2 products. And about 3 years back, when I joined AWS, I was working on storage and memory technologies given my background. And one of the first things that I was asked to do was figure out what are the most stringent use cases for memory and storage, who really stresses them, and then figure out a way to optimize them. And guess what? The people that I worked with are sitting here in the room, Srini, Lindley. I worked with them over the last 3 years because they really, like latency is super, super critical for them. So I'm going to talk a little bit about what that journey has been, Aerospike and AWS, and how we have partnered together to bring real-time use cases for our customers. So based on what Lindley already talked about on the various customer needs, and the fact that Aerospike wants to embrace machine learning and generative AI, AWS was an obvious choice. When it comes to performance, Aerospike is a real-time database who cares about very high throughput at very low latency. On top of it, you add the fact that you want to add machine learning capabilities, which is integrated through the store offering as well as VectorDB. They wanted a high-performance cloud to meet their customer requirements. Dealing with millions of transactions per second, or sometimes I in fact have worked with the Aerospike customers who are dealing with billions of transactions per second at a at a millisecond or less amount of latency is core to their business and to their customers. And that is where AWS really comes in with the variety of offerings that we have. So from a performance perspective, how do we deliver all this transaction that can scale up based on demand and can meet the customer SLA? So that is important. But not only performance, from a customer perspective, they also want to make sure that the cost is optimized. Ultimately, Aerospike, the idea of Aerospike is that they want to deliver highest performance at the best price performance advantage. So that was core to how we want to enable Aerospike on AWS, delivering leadership performance, delivering leadership cost profile. Apart from that, the customers that use Aerospike on AWS, they deal with tons of data, meaning you're talking about petabytes of data and the scale of transactions that I already talked about. So when you have so much amount of data to be crunched, not only you need good processors and a significant amount of memory and storage, you also need network and high throughput network, low latency network, so that you can deal with all these transactions. And that is where AWS Nitro system also brings its own advantages. The last thing, Aerospike wanted to make sure that the cloud provider enables their solution globally and can be secure and reliable, meaning their customers are they have variety of use cases across financials, manufacturing, real-time, edtech, and all of these customers, they have footprint all across the globe. So for them, they need to have ability to scale across the globe to meet their end user reach. And that was, again, important for them. So as far as AWS is considered, we offer Aerospike and their end customers many choices. Choices in terms of what we can deliver in computing capabilities. Here, when I say computing capabilities, I'm talking about selection of processors, the amount of memory capacity that you can have, the memory ratio so that you can optimize for cost, storage, networking choices. We are talking about operating system, payment options, payment plans. So there are many choices integrated into all our offerings. In fact, we have one of the richest portfolio of products within cloud, with more than 750 instances available on cloud today. Apart from that, when we have a modern EC2 instance, which is built with AWS Nitro system, then it does support highest possible compute performance. What I mean by that is that a EC2 instance with AWS Nitro system will deliver up to 15% more compute performance compared to a comparable instance from another cloud provider which does not have AWS Nitro. So there is definitely an advantage that you get in terms of price performance and performance benefits. So as far as the journey of Aerospike is considered, considering that they are a real-time database use case, the two big things Aerospike cares about is high throughput at a given latency. And while meeting an SLA of about 200 microseconds. So given the fact that latency is so important and latency variability is so important, they wanted to make sure that the storage aspects of our offering, it's such that it can meet their SLA as well as optimize the TCO for their customer. The journey of Aerospike started with AWS using their core database. That is still predominant. That is still the predominant usage of Aerospike on AWS for our mutual customers. That said, over a period of time, as Lenley mentioned, they have enabled Aerospike Cloud, Graph, and VectorDB on AWS as well. So the offerings have just gotten richer, where more options are provided to our customers. In terms of the instances itself, I4I, EC2 instance I4I and I3EN are the workhorses. They are able to process millions of transactions per second, and while providing very low latency. So these are the real popular instances that run Aerospike use cases. Apart from that, when we were developing Nitro SSD, so AWS Nitro SSD is our own custom-built storage solution. And I remember when I joined AWS and we started looking into, okay, how do we make sure that our Nitro or storage solution are really going to meet the most stringent requirements that are available or being run on AWS Cloud. And one of the use cases that really came across was the Aerospike's real-time database use case. So here we wanted to make sure that the latency and the latency variability is as tight as possible. And for that, Aerospike had created something called ACT, Aerospike Certification Tool Test, to test the storage latency. So we partnered with Aerospike and we optimized our Nitro SSD specifically for Aerospike use case, where the new generation Nitro SSD based instances offer up to 4 times ACT compared to previous generation i3 instance, or up to 2 times ACT per drive compared to previous generation i3EN instance. So generally a lot of work had gone in to really make sure that we can optimize these use cases for Aerospike. Not only that, we were able to reduce our latency significantly such that Aerospike was able to see 70% more performance for a given latency, which ended up resulting in 25% improvement for customer TCO, which was a huge benefit for the end customer. So that was great as well. And our partnership with Aerospike does not really end here. We worked with Aerospike on enabling Graviton, which delivers the highest compute performance in cloud, as well as delivers the best price performance. So a lot of work has been gone in to enable those solutions. So if you do want to benefit from highest performance, you have sustainability goals, then Aerospike with Graviton would be an awesome solution. And apart from that, as Aerospike continues to engage with machine learning and embracing that technology, we would be partnering with them to make sure that all the future offering are integral part of how Aerospike is optimized on AWS. Given that, I would like to invite Shai from Riskified. Sorry, Shai. Here you go.
Thank you. Hi, everybody. Can you hear me? Yeah. So nice to meet you. My name is Shai, and I actually fill in for Guy, who's supposed to be here today, and he prepared the session and everything, though because of the situation in Israel, he couldn't make it and asked me to fill in for him. So I hope that I will do justice to his short session. I'll talk a little bit about Riskified, what we do. It works. So Riskified is a company that exists for the last 10 years or so, a little bit more than 10 years, and went public 2 years ago. We have about 750 employees. Most of them are in Tel Aviv office, but the rest are spread around the world. We have a big office. The headquarters is actually here in New York. And we're spread about 180 countries where we provide services to customers. We deal with a lot of transactions per day and a lot of GMV that we actually provide services to, which I'll go into in a second. And we have very, very good retention rate. And I think part of it is because of the architecture and because the business model that we have developed over the years. You can see the list of some of our customers. We mainly provide services to very, very big merchants around the world that have a lot of traffic. And it's nice to talk about it in Cyber Monday, which is probably the highest. Well, there's a competition between last Friday and today, which one is the highest traffic day for those merchants and obviously for us. So the fact that I can stand here and not in the war room or something is good. It means that the system is reliable and stable and so on. So what we do, we have a platform of services that helps all those merchants fight fraud. We collect all the customer data which is related to the orders. We get all the information from all the customers, and we run our magic around it in order to say for each one of the transaction if the transaction is fraudulent or not. If it is, we will say so to the merchant and they will decline the transaction, and we also take the liability, which means that if we decline the transaction, sorry, the opposite. If we said the transaction is good, it's okay, and it's eventually a bad transaction and it's fraud, we will pay for it. In order to be able to support this level of liability and responsibility, we have to be very, very accurate and to trust our system. So this is why we had to architect it in a way that we can trust it so much. This decline approve of deals is what we call chargeback guarantee, which is our main product. We also have in the platform, that's not for me, we have some other products that complete the platform, which deals with preventing account takeovers, protecting abuse of policies in customers. For example, if they want to limit the number of items that they sell in a certain geography, or if they want to fight people that ship back empty boxes, for example, or fill them with sand and send them back. All kinds of things like that happen. And we know a lot about the identity of the customers, and we are able to identify what's the probability that this will happen. And when it happens, we signal to the customers, and they can fight it and can prevent this form of fraud as well. In order to do that, obviously, we collect huge amounts of data from all the customers. We link all this data together, and I think that one of the biggest effects that we have is what we call the network effect, which enables us to try and look in all the data from all customers and identify if there's someone which is believed to be a fraudster or abuser of a policy. So we have all those domains. This is a very schematic figure of how it works, what the flow and what the problems that we're trying to solve. It's just a very little flow from all what we do. But this is the one where we chose to adopt Aerospike as a solution to begin with. We are fairly new partners with Aerospike for the last 2 years. And I think it brings a lot of value, as you will see. And hopefully we'll be able to use it in other use cases as well. So domain services are all the data collection that we do, integration with all the customers, bring the data in. All this data goes into our platform, and we need to be able to provide this recommendation of decline or approve in real time. Why real time? Because we have some customers like Grubhub or DoorDash, which needs their answer right now. Otherwise, it will not be relevant. Some other customers don't care so much, so it can come a little bit later. So it could be like online or a little bit offline. We do all this in an order flow. We created what we call OFE, which is order flow event, which is signaling the status of the order on its way to production, what we need to do with it. And we needed to create some kind of a source of data that will be one source of truth for everything that we do with the data later on. This goes both to the live and online systems, like the real-time decisions, and it goes to the model training. A lot of what we do relies on model training, AI models, and obviously it should go to the billing and should speak the same language because it should be very, very accurate. You bill for exactly the transaction that we processed and everything. And the rest goes to the BI systems, to the data lake, and then the BI system. So we can use it for financial services, business analytics, and so on. If I take a little bit of a deeper look into the architecture, this is where we actually, about 2 or 3 years ago, we came to the conclusion that the previous technologies and architecture that we use will not scale and will not bring it to where we need it to be. And we started to look for solutions and happily found Aerospike as a good solution for those situations. So again, we have the service domains there in the left, collecting all the data. Then it goes via Kafka into our OFE events processor. And this is kept as practically as raw data to the first instance of Aerospike, which is really, really fast and reliable and really provide a very good solution for that. From there, we have all the services that we use in order to enrich the data, aggregate the order journey, and everything that we need to do with the data in order to process it and prepare it for the next steps. Then it goes and being stored in another instance of Aerospike. From there, we can provide the services of real-time data decisions and ML model training, and this is like a loop, closed loop that goes together and provide better accuracy over time. And when we talk about like AI models, we train a lot of models. We have high segmentations because we have very spread amount of customers from all different geographies and from all different spaces. So you need a solution for each one. And even for the same customer, we have several models. So we are talking about hundreds of models that we need to train and retrain and always play with it and bring it to a better state and better accuracy so we can, again, count on it and provide very good service to the customers. Then on another flow, we take all this data, both the raw data and the aggregated data, and we stream it into the data lake. Within the data lake, it's stored differently, raw data and aggregated data. And this is used for the other flows, which involves billing, financial services, BI, as I said earlier. So this is roughly the architecture that we use now. And we've seen that it helped us a lot in order to achieve the things that we wanted. One of them is scale. We are currently in a position, because of the horizontal scalability of the system of Aerospike, we can scale it as much as we need. So even if we get to a situation like the holiday season and we know that a lot of more traffic is coming, we can easily scale it up and make sure that we support this traffic with no issues, which is really important to us. Second thing is getting to the level of reliability and availability that we need. System needs to be available because if it's down, our customers suffer from it, they will experience fraud, and we will be liable. So both for us, it's really important, and for our customers, and we need a system that will be very, very reliable. It's a mission-critical system for those customers, and it's important. Cost efficiency, obviously, nowadays and any day, is something which is important, and we try to optimize it as much as we can. We use our partners from AWS here a lot and use gravitons and other technologies that help us to reduce the cost. And also the licensing model that we use with Aerospike is good because we know that when we scale up and we have more traffic, it does not automatically and linearly goes up with the cost, and it helps us a lot monitoring and managing the cost of the system. And performance, as I said earlier, performance is really critical. When I talk about performance, I talk not only about latency and the response that we get in matters of seconds, so sub-seconds. Also, performance from accuracy point of view. We need to be very, very accurate, again, both for our customers and for us, so we know that we're not losing money over chargebacks that we need to pay and things like that. So this is basically it. I hope that it covers and you understood the flow, and thank you.
Thanks, Shai.
I didn't introduce you.
Awesome. Thanks, everybody, for coming here. My name is Ujjwal. We at Freewheel have been using Aerospike for more longer, since 2016. And I'm going to share our journey here and how Aerospike powers our business. But first, a quick background about Freewheel. So Freewheel is a part of Comcast Advanced Advertising. We basically help serve ads for over 90% of top media companies across US and Europe. Freewheel powers successful ad campaigns on some of the most prominent live television events, including Super Bowl, World Cup, Olympics, March Madness, Sunday Night Football, quite a lot here. Our vision is to enable the largest premium marketplace where buyers and sellers can unite and securely transact, in which that drives maximum value for their business. So with that background, I wanted to have a quick check on how many of you are familiar with programmatic advertising. All right, so this slide would set the context on what I'm going to be talking further. So in programmatic advertising, pretty much in the world of ad tech, there are essentially several parties. Let's pretend a user is watching nightly news on NBC on a streaming device. So the publisher in this case, which is NBCU, have ad spaces that they want to sell. And the advertisers, let's say Toyota, have a demand to buy these ad inventory to promote products. So it's the ad inventory and the demand. So whether you're watching your favorite show on an ad-supported streaming service or visiting a web page, multiple advertisers are trying to bid for these ad inventory and trying to get your attention. And essentially, the highest bid gets your attention and gets the ad. So while tools that are used by advertisers are called demand-side platform, the supply-side tools are called SSP or supply-side platform. So just the terminology. So if you see on the right side of your screen, this graphic is just telling the extent of options a viewer today has to consume content. And as you see here, the publisher are trying to maintain their inventory across all these endpoints, while advertisers want to reach your attention across all these devices. So at Freewheel, we have a suite of products for the supply side and the demand side. And Beeswax is the product that powers our demand side product. And we use Aerospike to power both sides of the stack. And I'm going to explain how Aerospike really powers our Beeswax product. So just to get the demand scale at Beeswax, so we're getting around 216 billion bid requests a day. That's around 2.5 million every second. And we have to respond to them in milliseconds. And our bidder literally gets most of them in 30 milliseconds. So under the hood, there are technology choices to run this complex system at pretty much sub-millisecond latency at times. And we allow our customers to access premium programmatic inventory while offering them all possible customizations they can make to run their business. So designing such a system to handle this scale requires careful engineering choices, and I'm going to share how we do it. So one thing is clear here: to handle this sheer volume, we need a distributed system. And this is where you can see a lot of services that are put to use in running our system. So the web stack, it's a RESTful API. Our users can come in, create campaigns, upload creatives. The serving layer, which essentially handles the whole bids, is a high-scale distributed system. It processes millions of requests per second. The user data is another large-scale distributed system that handles collections and storage of users' profile from, again, our first and third-party data providers. And finally, on the right, you can see the reporting and the optimization components. These are essentially giving actionable insights to our customers and going a feedback loop and pretty much making sure that the user data components are getting all the information back to as a feedback loop here. So you can see here that Aerospike sits here right at the intersection of serving and user data. And it's essentially our, it's not advancing. Yeah. So one thing we don't want to do was build our own Aerospike. So our working principle has been to work with experts in this space so that they can do the heavy lifting. And that is why we decided to partner with Aerospike. So if you recollect on the previous slide, a viewer can be on any of those hundreds of endpoints. And as a DSP, we need to offer our customers the ability to do real-time user filtering, bid augmentation, a lot of things that they really need to run the business. So as I said, our customers control what auctions they want to receive. The filtering can be based on segments like zip code or apps, or let's say a list of fraudulent IPs they want to exclude. And this is very important for brand safety. Some advertisers do not want to advertise on, let's say, gambling apps or in a particular state. And all this needs real-time decisioning, whether we should accept the bid or drop it. And should our customers do decide to get the bid request, we also support bid augmentation. And that means we can add certain things. We can do a quick sub-millisecond lookup and add those additional information to make the bid more intelligent. So this could be adding latitude or longitude information. This could be adding weather-related data. Maybe somebody wants to target their users in a particular geolocation when it's raining. So you can see how these use cases can evolve. So there's another interesting thing that we do as part of this lookup is connect identities across users. So you can have one household having different individuals, and we can connect them with cookies or device IDs and IP addresses like TapAd and LiveRAM that we use to really connect them through the system. And that's where we use Aerospike to load all that information in real time as it comes so that we can serve those use cases. One interesting thing here to point out is in ad tech, the ad exchange will not or drop the bid requests which are received after a certain amount, let's say 100 milliseconds. So all these additional functionalities, as much as we want, have to happen within a certain time frame. And if you add the network latency to that, you really literally get 40 milliseconds or so to make all these decisions. And more features we add, we need to make sure we respect and don't exceed that. So safe to say that low latency, but also at a very significant and high throughput is table stakes. And any DSP would really want to have those at their core. And that's why Aerospike here is our flagship data store to run that. So I'm going to quickly go over the topology that we have. It's really not complicated, and that's the best part because most of the heavy lifting is done within Aerospike. So we have use case specific clusters. So if you remember in my previous slide, we do bid augmentation and filtering. So they are their own clusters, which we can scale up or down. And they're receiving around millions of requests per second. But if you see the latency, at least at P50 is less than 1 millisecond, which is remarkable. And in our case, if we do a segment lookup, and as I said, segments get updated, people move around, change locations. The throughput there is around 40 million requests per second. And again, we could achieve that using our Aerospike within less than 1 millisecond. I should also point out that the topology you see here really leverages used to leverage the i3s with NVMe SSDs, but we have moved on to the i4Is. And this is powered by the Nitro SSDs, as Amit mentioned previously. And we saw significant improvement right out of the gate. And at this point, we are actually actively exploring the Graviton instances and can't wait to see what other significant efficiencies it brings. So to conclude, we have seen many stages in our Aerospike journey. One thing is for sure, the request and the volume of data has been on a constant rise for us. There's one thing that stands out is just the jaw-dropping predictable performance. The scale of our bids, and it grows. And we have tried different things in the past across Freewheel, MRM as well, and the performance of Aerospike just stands out. And this makes a reliable choice for any real-time bidding or audience-related products, where quick lookup is at its heart. The other thing that we really use a lot is the storage options for namespaces. So if you're familiar with Aerospike, it gives you these options to choose how you want to store the data. You can have it be persisted on a drive, on a disk, or it could be in a real-time flash. So all those options are offered just out of the box from one stack. The third thing we use often is the high availability and consistency. So this is, again, inbuilt within Aerospike. We use the cross-device replication here just to make sure our data is in different availability zones. And XDR is this out-of-the-box capability that's provided. We don't have to do much just other than set it up, and it just works. And the last thing is the support for mixed workloads. So we are excited about the launch of the graph support within Aerospike. And at this point, we are working on identity graph, and we see quite a lot of potential in Aerospike to pick up those use cases so that we have a single place to go to for most of our workloads. So with that, I would hand it over to Lenny.
Thanks so much, Dr. Wall. So I have to say that both Shai and Ujwal went over some use cases that have astounding levels of transactional volume, okay? And that do it, with P99 of, single-digit milliseconds, right? And that's what I mean by, being in the present, as close to the present as you can be, and making decisions. And I think that this extends on to not just, ad tech, not just fraud, but anywhere you need to apply model-driven decisioning in real time. And so we can do this at whatever volume is required, really. So, Aerospike 7 is interesting because, and I have to say, I did not pay Ujwal anything to say that we support multiple storage models. It was great that he had that slide in there, but we recently released Aerospike 7, and what we did there was make a change to how we're handling the data in memory, in our shared memory, so that we can have warm starts for in-memory workloads. And you can select in-memory versus our hybrid memory or all flash within one cluster. So you can say, I want this for this part of the workload, another storage model for this part of the workload. But this release, we focused on the in-memory a bit. And we also can support compression, because if you want to be fast, having it all in memory, it's great to be fast. But with the advent of Graviton, where you get a lot of gains on computation, right, you can actually do this in an efficient manner and support compression for your in-memory workload. So you can do more data per node there. And the in-memory namespace is also reflected back down into the persistence layer so that you're not going to lose anything. So we have a lot of people that choose in-memory for some of their workload. And as I said, this is selectable on a namespace basis. And if you're new to Aerospike, namespace equals database, the way Oracle would use database in an Oracle instance of the Oracle database software, right? So you can pick it in a single cluster based on that. So this gives us this ability to say, I want, sub-millisecond capability. I want single-digit millisecond capability using the hybrid memory architecture. And just a quick word about the hybrid memory architecture. We essentially treat the SSDs as a memory space, if you will. So, on a large instance type with a lot of SSDs underneath it, you can have multiple terabytes per node. We did a petabyte benchmark with Amazon, that's a couple of years ago, but we had 20 nodes, okay, to do a petabyte benchmark. We were doing the kind of throughput we're talking about. The other thing that I'll mention quickly is that, with Graviton, it's not just that our database runs on Graviton. All of our client software for the application runs on Graviton as well, enabling all of the application to be ported to Graviton, as well as our database running on Graviton. That gives a tremendous cost savings. And this is what it means to be efficient across the board. We really focus on that a lot. So, we've been known forever as a key value store. We have something we call collection data types, or CDTs, that give us the ability to persist objects. and to support Spring data. We also fairly recently this year, introduced a graph service on top of Aerospike that gives us the ability to do the type of identity graphs that Ujwal was referring to. And we're at work in the lab now, and you'll see it in our booth, with a vector solution. And so the thing that's common across all of these is this, maniacal focus on high throughput, low latency, being able to scale out and be elastic, as was referred to, a couple times here, so that when you have those bursts of activity, you can scale ahead of it. And that's one of the beauties of the cloud. That's what the cloud brings to all of this. And, as Amit said, we continue to work on an ongoing basis with AWS, understanding what new instance types they have. And as we get into vectors, we'll start looking at how we'll exploit GPUs for some of the vector operations. But the storage mechanism will be the foundation of what we're doing here, and that's something we've been working on for quite some time. So, the real-time database for the AI future, from our viewpoint, is that you have to be able to handle lots of data. We have a customer who one time we were talking to them, and I said, how many different ingestions do you have, different streams of ingestion? And, the other person on the call with me and myself both, we said, 5,000, that's a lot. And they said, it's not 5,000, it's 50,000. And today, it's 100,000 plus different streams of data being ingested into Aerospike simultaneously all day long. And then they're also doing reads against that data to generate models. So, the ability to have a feature store at the edge that might be running all in memory, that can, respond in sub-millisecond, and then being able to bring that to vectors as well, and support diverse data models. As we said on the previous slide, it's not just key value, it's, compound, complex data types. Think objects and persistence of those objects as documents, and graph and vector. So thank you.